Alrighty. So as always, we're going to go ahead and start with some of the updates of what's happening on the semantic kernel side, and then we can open up to Q&A and see what folks are building out in the community. So on the semantic kernel side, I think the main things I want to share with you are our progress on those top items that I mentioned in previous office hours. So that's AI connectors, so more AI connectors, more memory connectors, and improving our memory connector story, and then agent. So for most of these, we now have some ADRs that are currently in progress, kind of describing what our potential strategy and plans are in these various different spaces. So I just want to highlight these and make sure that this community is aware of them, so that if you do have any perspective or feedback on these different ADRs, that you can share them in the comments and as feedback before we merge them in and eventually actually implement these features. Just want to share them in the chat. So the first one, we are looking at reevaluating how you do RAG, retrieval augmented generation, inside of semantic kernel. Today, we have our memory connectors, and you can use them inside of your prompts using our, I think it's called the text memory plugin, that allows you to inject information into your query. And this is kind of what, where is it? Here we go. This is kind of what it looks like, where you can call the plugin and you can send in your question. You can kind of get answers back. This is likely what we'll continue building on, but there's a few other options. And if you like another option particularly more, please let us know as part of the PR. Okay, so that's one. So we're trying to improve RAG. You can see kind of our different proposals. I think we have 5 or 4 that have been coming up. And as you can see, we haven't come up with a decision yet. You can help us land on the right proposal. The other ADR that I'm going to pull up, actually, this is just a sample, I think. This one might have already been checked in. Let me just ADR connector. I think it's no longer open. Oh, okay. So I think I mentioned in previous calls that we are wanting to improve how we can actually bring in new connectors within semantic kernel. It's been really hard, frankly. One of the connectors that we really want to get in right now is the Gemini connector, and the initial PR for that was over 11,000 lines long. And it was just really hard for our team to do an adequate job actually reviewing all of that code and making sure that it landed inside of our repo correctly. And so what we are going to be doing moving forward is using a feature branch strategy for any new connectors. And I think inside of the ADR, we actually highlight the types of connectors that we're hoping and looking for community support to build. So you can kind of see here, these are the different models and the priorities that we have for them. Phi, Gemini, Llama 2, Mistral, Claude. Hopefully all of these names are familiar to you and ones that you're interested in. And then as community members say, hey, I want to help contribute different connectors to things like Anthropic or Amazon's service or Gemini's Google AI, we will work with you and create a separate feature branch so that you can do smaller PRs to add information, add capabilities to your connector so that we can have an easier time reviewing it, checking it in. And then once the connector is finally done, instead of having a mammoth 11,000 line PR, we can just take what you've built, merged into the feature branch, and merge it into the main branch. So this is just a helpful FYI to anyone in the community that's wanting to add a new connector. We've created a new process that will hopefully make it easier to get your work merged in. Okay. And then the last one, this one's still currently open, is all around agents. We're still in the, I would say, fact-finding period. Sergey on our team has started identifying kind of like what the context and the problem statements are, grabbing examples from what we've built on top of the OpenAI Assistance API, and even things in AutoGen. So he's provided some sample code of what our agent abstraction could look like if you used it inside of the ADR. Again, if you have any feedback on these different patterns, if you have scenarios that you would like to see supported with agents that you aren't seeing inside of this ADR, please let us know through the comments. This is the time to let us know since we're still in the fact-finding period. So I'm going to take a stop there and see if there's any questions about those three different areas. So your memory connectors, your AI connectors, and agents. It looks like we do have one hand raised. Tristan, why don't you go ahead and go?
Yeah, so I think we're feeling a little bit paralyzed with the Assistance API being out there and not, like, at least in the OpenAI world, if not the Azure OpenAI world. And we're initially expecting that to land in SKV1, and maybe we formed the wrong view there. But just kind of our own internal development efforts sort of are hinging on that, I guess it feels like, and maybe we're putting too much emphasis on it. But for me, it feels like the memory connector space is like for scenarios where we in future choose not to use the Assistance API. And there might be good reasons for cost or whatever, hitting some non-OpenAI model or whatever that we want to do that. But yeah, I think for us to really feel massively invested in it, we need to understand what's going on with the Azure OpenAI Assistance API whenever it might come. Does that make any sense? And how that might land in Semantic Kernel? Because for us, it's like we want to align to that. We've got things that we don't want to update in our code, right? And so right now, we have these plans on hold. We're waiting for a Semantic Kernel to adapt to something that doesn't exist in Azure OpenAI, and then we don't know when the Azure OpenAI thing's coming. So it does just kind of stop us in our tracks a bit.
Yeah. Because what I'd say to that, we were expecting the Azure OpenAI version of Assistance to be in preview at this point. I think they're tying up some loose ends. So my expectation is it's coming soon, but again, I don't have any like concrete dates I can publicly share on this call. So maybe we can have a sidebar chat on that particular topic. As soon as that's available, because we already have the abstractions in place, we should be able, within like a few days or a week, be able to point ourselves the new API. So we're not talking about months being able to support this.
That's
this
really helpful to know.
The one caveat I will say is our integration with the Assistance API is experimental, and the main reason being is we suspect/know that our current abstractions for agents is very much tied to Assistance API, almost too much. And so we do think that as we kind of look at the rest of the ecosystem like AutoGen and start asking ourselves, how do we build an abstraction that works for custom built agents that you don't use Assistance API? Can we actually support that in a reasonable way? So I would expect some of the APIs to change their structure, which would require some breaking changes to the experimental package. But I won't imagine like catastrophic change if that
Sure.
makes sense. So that would be the thing I would keep in the back of my head is like things may change if and when Azure OpenAI supports Assistance. It'll be very short before we support it as well. And yeah, you might see some changes afterwards. Great question.
Amazing. Thank you.
Cool. And then Renee.
Hi, nice to meet you. I'm the first time here. And I'm coming with two questions where I'm with my customer implementing more of a rack plus functions, function calling. And we have two questions with Semantic Kernel. First one is about the planner. If you have a chat experience, what are, let's say, the best practices or maybe examples where we can actually decide when to invoke the planner, right? I don't want to invoke the planner all the time. For example, when I look at the Copilot chat sample, it always tries to invoke the planner when the plugins are enabled. And we would like to decide when it makes sense to invoke the planner for more complex tasks of a user. And if just the guidance is to more implement as a plugin and go that direction, or what are maybe even the samples if there are somewhere from the community which we could look at to learn from how to the best do the planning invocation.
Yeah. So what we started to recommend is what you mentioned, turning planners into plugins so that the AI can choose when to call it. So we do have a sample in our Learn documentation. I'll go ahead and just pull that up real quick so you can see what it looks like. So we have our planner here. If we go inside of the program, we're only loading in one plugin, which this is, I'll show you what it looks like in a bit, but this is our planner. But you can imagine actually having multiple plugins that are all each themselves a planner, right?
Mm-hmm.
So you might have a planner specialized in solving math. You might have a planner that specializes in sending emails. You might have one specialized in doing sales orders, right? So at the top level, where your Uber agent, you could create these things that have multiple planners attached to them. And then if we actually look at what this math solver looks like any other plugin, it has some inputs. In this case, we're trying to get that goal. We're using prompt engineering to make sure that we get the right information from the parent agent to actually correctly run the planner, right?
Mm-hmm.
So if you need your planner to extract particular bits of information or context from the main chat, this is a really great way of doing it because you can have multiple inputs and craft a goal for the planner. You then, of course, then run your planner and return the results back to the parent agent. So that's kind of how we imagine using these planners inside of a chat-based scenario. Great question.
Yeah, and maybe the second one, this is very helpful and that definitely enables us. The second one is coming more from the UI experience, and that's more, imagine you ask a question and sometimes you want to give these quick proposals like Bing Chat, basically referring to that sometimes Bing Chat has these quick actions like generate a page summary, or maybe based on your plugins, it provides you the suggestions for the workflow. Is that something like, what would be like the recommendation in this? Shall we maybe from the context figure out what are, let's say, the recommendations, what we could pose to a user, or is there, let's say, a functionality which is maybe faster than invoking LLM to get those suggestions?
Yeah. So I've been personally where I was like, okay, how can I do some predictive stuff to help the user? I will share my own experience and what I've done. We don't have anything like natively baked in the kernel that makes this like, I would say, quote unquote easy. But what I have done is just created a very simple prompt function that basically says, hey, here's the current chat history. Can you predict what the user is going to say next? I've been treating it more like as an autocomplete feature, so I can like type something and hit tab to autocomplete it. For your suggestion feature, asking the LLM, hey, return the 3 top things in this JSON format, right? So that you can parse it and then display it as little chiclets or tags. I don't think it should be too difficult. And I think that's probably one reason why we haven't natively baked it into the kernel. But give that a whirl, see how far that gets you. And if we start seeing more people wanting this pattern, maybe we'll bake in or provide a sample within Semantic Kernel. Good question.
Thank you.
Pradeep, I see you have your hand raised, but I also want to give some folks some love in the chat. So I'm going to actually, Pradeep, you're the first one in the chat. Okay, so if you want to come off mute and tell us a little bit more about your use of the handlebars planner.
Yeah, hi. So my kind of question is similar to what Renee was asking. So we use the handlebar planner today, and the things we find the most expensive operation is creating the plan, right? And the way we thought we'll approach it, because the handlebar planner allows you to cache the plan. So we cache the plan, and because the plan itself is specific to a given user input, we templatized it. And then the idea was next time a similar user query comes in, but let's say with a different set of inputs, right? So now we use LLM to extract the inputs. That is a very fast operation. Then we populate the templatized plan, and we kind of re-execute, right? And we find this is pretty fast as opposed to creating a plan each time. Wanted to understand what your thoughts are on this approach, and in the future, could we expect the planner itself to emit a templatized plan as opposed to a specific plan?
Oh my God, you make me so happy.
That was a long-winded question. Sorry. Yes.
No. The reason I'm so happy is like our team's been talking about like, oh, we want to be able to like cache these plans. They should be like parameterized, and oh, it would be great if you could then use vector similarity search to like retrieve a plan and like hydrate it with the specific.
That's exactly what we're trying to do. So.
Right. So great. We have someone that's trying to do it. Maybe not successful. I guess I'll let you speak to that. We know that the handlebars planner does not make this easy today because we basically hard code all those values, as you kind of mentioned. We do want to get to the point where it is templatized and it gives you like, oh, these are the inputs. So that's one step that it sounds like you've already had to code around, that hopefully we can make easier for you. So that's one. And then two, we will probably not get into the business of actually providing the infrastructure or SDK for doing that retrieval of the plan and hydrating it, because that'll be very specific to each use case and vector database.
Yes.
But we will probably provide a sample at some point that demonstrates exactly what you're describing.
That we're hoping we can use what semantic memory offers today and do it, right? It's fairly easy, I think.
Semantic memory, yes. You should be able to use that. The thing that I am cautious of or uncertain if it will work or not is because each question comes in with different inputs. Those inputs, I fear, could be enough to sway the embedding so that it grabs the wrong plan or plans, right? And so I think there does need to be some research, some work to figure out like what is the best way of taking a request, almost like scrubbing it of inputs so that it can better map to a plan, and then only after that mapping is occurred, bring the inputs back in and funnel them into the.
Yeah, what we were thinking is, in our case, we have API maps to a plugin, right? So we were thinking we'll actually put the plugin definitions in the vector database, and we'll also map each plugin, let's say, corresponds to a particular user query. So it can map to a cache plan is the way we were thinking about it.
Okay. Yeah. This is where it gets into theoretical territory. So yeah, if you want to give that a whirl and tell us what does and does not work, we can start baking that into the kernel and providing.
Oh, thank you. But it does sound like a plausible approach, right? We're not like totally off the charts here. So
no,
okay.
You're right on track. At least, like I said, I don't think I've seen anyone actually finish this end to end. I've seen a few customers start it, and we've been supporting them. And fingers crossed this pattern works, because it would be huge, right? Because you're right, the most expensive part is creating the plan, and if we can cache it, that'd be great.
Perfect. Maybe if it works, we can come and show a demo in the future. So
yes, please.
Yeah. Thank you.
Okay. Zing.
Oh, hi. First of all, I just want to add a few words to your last conversation, Pradeep. I mean, because we have tried something similar as you just described here, trying to do cache plan, and by using the cache plan, we try to create a little module with the vector search to match user request to the plan with its metadata. I have to say it didn't work too well for us. I don't know. It's I just want to share what we experienced, and I was hoping that, I mean, like, we communicate, and maybe like if you found some other way to do that, I mean, we can take advantage of that as well. But I just want to share what we have experimented with. We did vector search, and the thing with vector search is that found is not as smart as the LLM. So essentially, I mean, we have we put the annotation and metadata of the plan, whatever it covers and all that, into a vector database and do a match of that with a score. But since it's still like a kind of a string match, I mean, with some semantics, but it doesn't handle well when the user's request does not really have too many similar words with other requests. You know, like for one question, people can just phrase it entirely differently with entire different words, but they are actually kind of same. And then at that time, the vector search doesn't work that well. So I mean, after a little experiment, we have abandoned that approach. And then I still have a task left open on my plate, which is to see, like, if I do some engineering with the prompt and the annotation, maybe with some parameter and some magic can happen to improve all this. But I haven't got a chance to get around with that yet. But I have to say, like, the pure vector match between user request and then the annotation. I mean, you can still try, but I have to say, like, there is a limit.
Thank you. That was excellent feedback. I think we will let you know how it goes on our end. So.
Yeah, so maybe we can connect, and I'm really curious to see how your experiment go. And after that, oh, sorry.
Oh, just real quick. I think, Pradeep, if you're using semantic memory, that kind of combines retrieval and the LLMs to like make a decision of like which retrieval was actually the right one. So I'm curious if that's the extra oomph to get you over the edge. Fingers crossed. Zhang, you had something else you wanted to share?
So I have my own question now.
Yeah, go for it.
So my question, I also put that in the chat so that, I mean, maybe that's easier for you to look, but I'll describe it. So my question is about the function calling stepwise planner, which is the one that we're using right now. In our situation is that we have a whole collection of kernel functions in skill. And basically the idea is that whenever user asks a question, that each of the kernel function is going to fetch data in a certain area, and we want the planner, the smart of LLM, to pick all the related functions and hopefully just run them in a parallel manner to grab all the data, put them together, and then compose the response eventually. So that's our situation. And then from the definition of it, it sounds like the function calling is providing that to run function in parallel. So we use the function calling stepwise planner. But from the output of it, yeah, because the first question is I want to know exactly how that works, because from the look of it, I cannot see that it's actually running the function in parallel. Not so sure about that. It feels like it's doing iteration. It's running a function, and if it gets the data, can answer the question, it quits. And if it doesn't, it will go on to call other function it finds useful. It seems like that way. Just want to confirm that exactly how that works, and if there is a way to tell it to run function in parallel. And another behavior I observed is that when you try to run this type of function one at a time in the iteration, sometimes you go back to the same function called earlier, like over and over a couple of times, which definitely is not something we want. And I just wonder, like, if there's any way to control that kind of behavior. And then I have other questions. So maybe one at a time. Yeah.
Let me jump in. So the way the stepwise or the function calling stepwise planner was created and the automatic function calling was created, we end up with two forked implementations of function calling. The one that has like all of the features is automatic function calling, and it includes parallel function calling. We currently have a PR out that is going to merge those code paths so that the function calling stepwise planner can also get parallel function calling. So to answer your first question, you aren't seeing craziness. We have basically a deficiency, or you might call it a bug, with our stepwise planner, which is preventing it from parallel function calling. If you want to start seeing parallel function calling today, my recommendation is use auto function calling instead of using our planner, at least today. So that's one. In terms of two, of it calling the same function over and over again, that's a bit concerning. If you do want more control, though, you could. There's a couple ways of handling this. Either you break glass and you kind of use the manual function calling, and you would have a little bit more control. The other kind of thought I have is you might be able to use events or filters in order to say, hey, you already called this function before, and instead of like running it again, telling the AI, hey, you did something wrong. And then just real quick, I'm looking at some of the other questions that you have. Are there better practices for the planner? For this particular planner, the expectation is you just kind of provide a goal, and we have a meta prompt that kind of breaks that into different steps. If you want more control, which it sounds like you might, if you again go to automatic function calling, you can create that meta prompt, and that might give you a little bit more flexibility and control of behavior that you're looking for. And then lastly, for kernel functions that are there some suggested practices for annotating? You remember a bunch of other things that were there before. So as part of our V1 proposals, we had things like, oh, we're going to have return and samples and what have you. We found that the out-of-the-box annotations within .NET were sufficient. You can basically put descriptions on everything. And so our recommendation is, if you're having trouble, go ahead and add descriptions on the return, add descriptions on your different inputs. Probably the thing that I have found most helpful, though, I'm going to go ahead and share my screen again. Actually, going back to the math solver problem. When I first built this function, I just said, hey, the math problem to solve. And the challenge that I have is the information that the LLM was providing wasn't rich enough for the planner to actually achieve everything that it needed. And so I had to add this extra line of text, which is describe it in 2 or 3 sentences to ensure full context. So the more you can actually quantify the type of information that you want the LLM to provide, the better it will be. So that's one. And then two, we don't have an example of it here, but the more you can provide examples and non-examples, hey, within the description, you could use this to solve questions like 2 + 2, but you can't use it for, I don't know, XYZ, right? We had in our proposal to introduce actual descriptions for good examples and bad examples. We decided not to move forward with that because we found that most folks could just add that as part of the description and they were sufficient. But yeah, I think if there's one example, you see all the different attributes that we have. So you have the description of the function, description of the return type, and description of the inputs.
So are all these descriptions going to be used and included by the LLM in prompting?
That's correct.
Oh, okay.
Yep.
I see. So follow-up questions on that. So first of all, I still have a small question in between, which is about output planner thoughts for debugging. And so, I mean, it print out a pretty comprehensive guide, like describing its thoughts, like how the things the system will say, like I'm going to do this and that to calculate that. So first of all, I'm going to call this function, which is good. But then it go into its iteration, like it call this function and then get output, and then it come down to say like, now we're going to perform the next step. And so that, but that message is generic. It's the same for every iteration after that. And it doesn't say like what's the next step is. So from the output, you have the system saying that I'm going to perform the next step and then provide the output to the final composing step. And that's it. But now knowing like what it's calling, I mean, and then it use the same message after that. So I just wondered if that's a just like a behavior that we can config. Like, is there a way that we can get to more information on what each step actually, like what kernel function it actually calls, that kind of thing? That's one.
Yeah. So, and this will probably be the last question, so I can go to other folks. If you do add, if you do add a logger to your kernel, this should log all of the different methods that are actually being run by both the kernel and the function calling thing. So that should give you all the information that you need. If you want even more control and information, I'm going to go ahead and go to here, go to our samples, and we can go to filters. So we have these filters, which you can add to your kernel. And whenever any function is called, you can get the information of what is the function being called, what was the results of it. So I'll go ahead and paste this in the chat. But that should give you that.
Yeah, because I was about to ask for the sample for when you mentioned how to use event and filters to make sure that same functions are not called within the main function. Yeah, it does. The sample will be great. And last question. When you mentioned that you're merging the paths from between automatic function calling to function calling stepwise, and you have a PR out. If that whole thing is done, when can we expect that feature to be available to us?
So I have a review later today, so I don't have a good answer, but I would expect within the next week or so they'll be out. I just pasted R for the current conversation.
Okay, cool.
Okay.
Okay, thank you.
Yeah, for sure. So Alexander, I'm gonna come to you in a bit. Let me answer a few more comments in the chat real quick. Jose says, is that not the usual way to do a PR? Do a fork, create a branch, and issue the PR. I'm assuming this is a reference to how we're doing connectors now. You're completely right. The slight difference is we are going to be actually creating a feature branch inside of the main semantic kernel repo. So as you create your fork and you create a branch, you will do a PR not on the main branch of semantic kernel, but the feature branch that you're wanting to build a connector for. So that's the slight subtle difference. And then Jordan asks, what are your thoughts on using memory versus directly querying AI search for the RAG pattern? It seems that memory should only be used for things that you know you're going to need. You should use the AI search for searching when you don't know. The more stuff you get in the memory, the greater it can confuse. This gets muddy when using AI search because it can also be the underlying vector store for memory. There are 3 approaches I see. They all use the same components, but in different ways. And there's some like diagrams. I think you're right. If you know the information that you need, like if we take a step back, the more deterministic you can be, the better. because that means your AI is less likely to do kind of weird, scary things. And so I don't think it's like choosing a particular approach. You're probably going to actually use all three. But depending on the type of information, you'll choose a different route. So if you know you're always going to need the user information, like their name, their location, or whatever it might be, right? Just hard code that into the template, and then you don't even need anything like memory or a vector DB, right? I'm just looking at these other patterns that you have. Pass relevant document symbols. And then I think the only time when you'd actually use vector memory or AI search would be to actually get information off of unstructured data. So your documents. And I'm trying to look at your diagrams. I think I might be a little bit confused. If you want to come off mute and kind of share what some of the differences are between these diagrams.
Sure. So the big question is around versions 2 and 3. So with the manual rag pattern, I can, via the Python SDK, go query AI search and then do string concatenation to inject what it finds into the template that I send on to the large language model. Yep. But Semantic Kernel also provides a way for me to directly reference AI search via an Azure data source. So is there a difference between those? How are those implemented? When should I choose one over the other?
Oh, okay. So this, 3. I mean, is this Azure OpenAI with your data? Is that the connector you're using?
Yep.
Okay, I got it.
Like the Python example shows how to do this. You directly register the index you're interested in, but I could also do that with just the Python SDK. So what's the difference between those, and when should I choose one over the other?
Okay, great question. So number 3 is using like special magic inside of Azure OpenAI. So it's not magic that's happening in Semantic Kernel. It's actually Azure OpenAI with your data. Using your data. So it uses this technology. I'll drop a link in here. And behind the scenes, what the Azure OpenAI team has done is they have built their own kind of RAG system. So as you call the model, they will automatically enrich it with data from the index and provide you some information. If you find that works for your scenarios, I would say use it, because it's only going to get better. It's a service that you don't have to deal with, and you kind of have warm fuzzy feelings going, oh, Microsoft engineers and Azure OpenAI are making this awesome, right? If, however, you find that
I meant the Python example. So the Azure ChatGPT with your data API.py, it explicitly shows you how to set up an Azure AI search data source that targets a specific index. So how is that different than me using the Python SDK to hit the Azure AI search?
Okay, you dropped the link. Okay, because either way, in both cases, you have to create an index, right? And then it's just a question of like how you query the index, correct?
Right. So in the first example, I would just use the normal AI search SDK to query it just like I would anything else. And then I would do string concatenation to take the result and inject it into the query that goes to OpenAI. But in this example, it's kind of bundled all together as part of Semantic Kernel. It's somehow magically calling the AI search for me and determining whether or not it ought to do that.
Correct. So when you pass in the index, it goes with the with your data APIs, using your data APIs.
Yep.
There's like, here we go. Okay, so this is the APIs that we use, and the people doing the magic is Azure OpenAI using your data team. And they do RAG to pull the right information and tell you the answer, right? If this works, use it. Awesome. If it doesn't work, that means you need more control, and you basically need a custom implementation of RAG. That's when you'd use the number 2, the doing it yourself.
Okay. But you also agree that we shouldn't inject all of the data that we could ever possibly need into memory, because that confuses the model. Memory should not be used as a replacement for AI search.
Correct. Yes. Wait. When you say memory,
Semantic kernel memory. Now, it
semantic
might
kernel.
be AI search as the vector database underneath, but it might not be.
Correct.
But we should still use AI search to index the large corpus of documents we've got.
Yep.
We shouldn't try to take all of those and shove them in memory and hope that it can find what we want.
Correct. Now, with option 3, that is kind of what you're doing. You give the index all of your information, and Azure OpenAI is the one that magically does that for you. Yep.
Okay.
Cool. Alrighty, Alexander, let me come off mute.
Hello, greetings, y'all. Well, I'm just like reeling on how intelligent everyone is here, and it's kind of crazy all this talk. That I understand 5%. I have a really simple question, comparatively speaking.
Go for it.
Yeah. So in LangChain, there's like a 1 to 2 line operation or query to basically grab an OpenAI function using get open API chain, and essentially you can natural language a question to an API, and it spits out the API result. My question is, in Semantic Kernel, it seems like we have to run the function register open API plugin, and then through a planner, basically pair that with the HTML plugin to do the same thing. My question is, like, does that make sense? Is that the format in which to go about this particular operation? Is there another way to kind of go about it?
So, I mean, you're in Python land, yes?
Yeah, I'm in Python land, yeah.
Okay. So, I will say, unfortunately for you, that is what it's like today. And I would say in a month or 2, your life is going to get heck of a lot better. Let me go ahead and just like share with you what the world looks like in .NET and what you're going to get fairly soon in Python land.
All right.
So, yeah, and this is just good knowledge for everyone, because I do get a lot of questions like, "Hey, I want to import." You said an OpenAI plugin, is that right?
Yeah, it's an OpenAI plugin with following like the OpenAPI format.
Perfect.
Yeah,
I get questions all the time like, "Oh, I want to do OpenAPI plugins. Is Semantic Kernel able to do that?" Yes, the answer is yes. So if we open up, I want to paste this in the chat. So we kind of show how to create a plugin that is an OpenAI plugin. And then in this program file, we can start to see what it's like. So as you mentioned, with Python, it's a little bit more convoluted, but in .NET, all you have to do is create a kernel, add in your completion service, build it, and then import your OpenAI plugin. Which it should be a URL. And then at that point, you can start just using it. So this example is kind of a chat scenario where we're using automatic function calling, so we don't have to use a planner. And if you do want to just call it individually, that's possible too. I guess what you're getting at is LangChain probably has a helper method that lets you call a chain that does all of basically this code in 2 lines. Is that fair?
Yeah, exactly. Basically, yeah.
Yeah. I'll bring it to my team to see if we will add some additional helper functions. We may or may not. Yeah, we'll have to have a conversation. Okay. One of the feedbacks that we've heard from LangChain is that it does a lot of like quote unquote magic behind the scenes, and people are like, what the hell is it doing? One of the values that I see of Semantic Kernel actually having you explicitly write, like, well, you're turning on auto function calling and you're going to call the function to get a result, is it forces you to actually interact with those base components and ensures that you actually understand what the hell's going on. At the same time, we do want to make it as simple as possible to get started. So I think that's some really good feedback to bring back to the team on Semantic. LangChain provides some really few line to get some samples like that working. Can we do the same thing within Semantic Kernel?
Yeah, no, 100%. I think like it'd be nice like to be able, and on that point that you just made, like it'd be nice to just have the examples like explaining the magic inside, like in Python are. It seems like in .NET Land that's already there. Whoa. That's fascinating.
Yeah.
Snakes and cats, apparently. Yeah. Examples are great, and explaining how those pieces kind of mesh together would be super useful.
Perfect. Okay, cool.
Thanks, man.
And actually, I think we have something on a roadmap that will make this pretty easy. Okay. Okay. Thank you. I don't see any hands raised, so let's just go back to the chat. We'll do a quick time check. We have about 10 minutes left. Jeevan asked, what's the plan for agents to be used with Azure OpenAI services? So the ADR I shared earlier with agents, that's kind of our goal. So as I mentioned, we're in fact-finding state. And I don't know, within the next month or so, we'll release these agent abstractions, and you'll be able to use an agent not just on Azure OpenAI services, but any model that you want to. And then Renee asked, Renee, did we already answer all these questions? I think I remember you raising your hand. Yeah, okay. I think we already talked about those. Alessandro asks some general questions about the new style of SK office hours. I missed the last two, and it's hard to go through the videos using new structure. It was very helpful to see the PowerPoint slides. Oh, that is good. That is good. It appears we now need email questions. Are we going to keep this new format or change it? So I'm going to give you a peek behind the covers of what the hell's going on here. So this is like super inside baseball. So we made some changes to the Semantic Kernel team. Alex, who used to help drive these things, he was asked to drive some more Copilot stuff across all of Microsoft. So he's not able to put in the time. To help with that, we are hiring a new community PM, and she will actually be joining in, I think, 2 or 3 weeks. I think February 17th is the date that's fused into my brain. So if you have seen digression or regressions in our community office hours, it's because poor Matthew is running around like a chicken with his head cut off, trying to make sure that everything still flies as we change out the airplane parts. So are we going to keep this new format? No, because I'm going to be asking the new community PM, your job to make this better. I do appreciate the feedback though, now on, hey, in the meantime, can we have some of the goodness that we had before? Yes, I can definitely do that. So during the next couple ones before we have the new community PM, I'll start pulling together the PowerPoint slides. It sounds like the main need is if you're watching the video after the fact, just being able to scrub.
Yeah. It's easier to scroll and go back and see things, you know.
Bon, 18h, bientôt le moment d'arrêter. Dis-moi.
Okay. So the scrubbing. Okay. So what I do next time is I'll open, even if I don't get a bunch of questions ahead of time, I'll just create an empty PowerPoint. I'll type in the questions so that folks can scrub. So thank you.
Cool. Yeah.
Okay. Let's see. A direction question. What are your thoughts about Llama Index, and what is the plan? Okay. So
there you go.
In terms of the memory space, it is so hard. I've actually started recommending to customers, if you have a choice between doing RAG and like, oh, I just want to automate processes with APIs that I have today, do that first. RAG is scary because basically what you have to do is, not only are you building an agent, you have to build an entire custom search engine to just feed the information that the AI needs, right? Like you're signing up for a lot of right? And to that end, it's really hard for us. And when I look at things like Llama Index, I'm like, wow, like they have it solved, they're the best. And there's no use in trying to compete with someone if they're as good as they are. The challenge is it's only in Python, and we do know that the folks that love Semantic Kernel, most of them are .NET devs. So in the short term, what we want to make it easy to do is for you to at least like talk to a Python Llama index and bring in that information within Semantic Kernel. We know that's not the ideal like long-term solution. So what I am doing is I'm looking across Microsoft, looking at teams that sponsor and build .NET libraries and SDKs and say, hey, will you sponsor a .NET port of Llama Index? I think that would be incredibly powerful and beneficial to the community. Obviously, we're just now in discussion phases, and getting funding is always fun. But that's where I hope we can evolve things. I don't want to build something slightly different. I'd rather just port the dang thing.
Yeah, you see, after the Elasticsearch thing for kernel memory, I started looking into Llama Index, and I see how they store stuff. There is an interesting comparison going there, but I mean, I had to learn this. I'm Python now. I moved. I can do Python.
Okay,
it's like,
okay.
There's a lot of stuff there about how they do the fetching of the documents depending on the type of. I'm like, wow.
Yes. So yeah, the person leading that project is a genius. So we can appreciate smartness when we see it. Okay, so we have 3 minutes left. Let's see if we can make this rapid fire for the last one. Okay, Alexander and LangChain Python. There is a one. Okay, we were talking about that. Logan, a little topic. What is semantic kernel support for models? Okay, so right now, the only like super official supported models are all the OpenAI ones, and either OpenAI or Azure OpenAI. I think I shared in the PR the list of models that we're prioritizing next. I think there was a question about getting access to that list of. Just pull that up real quick. So I'm just going to drop that in the chat, and that's how you'll know what is coming next.
Well, sorry, I actually mean support model of SK in terms of like long-term support and all that stuff.
Oh, got it. Okay, so 1.0 that is long-term support. So we won't, anything that's not experimental is not going to be broken. And yeah, Microsoft signed up for this thing. So we're going to support it. And we have, if you're curious, like inside baseball, like how much love is Semantic Kernel getting? Is it at risk to being defunded and deprecated and taken out back and whatever? We now have internal teams using us. We have sponsorship from it's called DevDiv. They own like VS Code and basically all of your typical .NET SDKs. So this is definitely escaped out. It's definitely no longer just like a research project or something being done on the side. It is an SDK that Microsoft is going to support now into the future. Okay. Great. Zing, we answered your questions. Marius, can someone share code snippet showing a plan based on a parameterized goal, which is then reused and reinvoked? Marius, I think that still needs to be done. So there's work on the semantic kernel side to actually have templatized plans, and then we'll provide a sample. Steve, anyone know if Azure AI Search is compatible with the larger new OpenAI vector embedding dimensions? Oh, that I don't know. So I'm going to skip that one. Tristan asks, 20. Oh, okay. They try to answer that question. Cool. More conversations about the embedding stuff. And Becky asks, I'm running into an issue where the conversation summary plugin works with my model 3.5 turbo, but not with 3.5 turbo 16K. That is weird. Becky, my ask is if you can create an issue for us on GitHub, we can take a look into that. That shouldn't be happening. Jose, never seen a team with so much push, and it has incredible rhythm, solid. Oh, thank you. I appreciate that. And then Alexander says, if you don't mind, find the link for this. That would be great. Plus the roadmap for Python, if that's okay. Okay, so we are at time, but I'm going to share the link real quick. Let me share my screen so y'all know what I'm clicking around like a crazy person. Okay. So if we come here, nope. If we come, okay, and then we are looking at closed. Community support. And then we go to the files that was changed. File. Okay. Okay, so this is the page. And then I will provide you a deep link with our priorities. You have that link. And then the other question folks had was around the Python roadmap. So I think last week I published this article. It is a very dense read. It's not my favorite blog article, but it does give you links to our public backlog for Python, so you can check out what that looks like, and kind of some high-level buckets so that you can start to reason over the main changes that are coming for Python. So I hope that helps. Alrighty, well, thank you everyone for a fun office hours. Thank you for putting up with me. Like I said, in a few weeks, I'll be able to introduce the new community PM, and we'll just keep making this better and better and better. Alrighty, cheers, folks. Bye.